Welcome back to Pocket Run. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Okay, we're going to be doing sum and difference identities today, and we're looking at 11b3, and this is sine of 105 degrees. Yes, we could put in our calculator 105 degrees and find out the sine of it, but the instructions say instead of using your calculator, you're going to turn this into familiar angles and use your sum and difference identity. The reason that we learned this is because at one point in the past, astronauts, NASA employees, they didn't have calculators, and so they had to figure out other ways to find the sine of 105 degrees using the information that they had already known. We know like sine, cosine, and tangent for like 30 degrees, 60 degrees, and 45 degrees. So when this says to turn this into familiar angles, that's what they're talking about. Use 30, 60, 45, and use those reference angles. And we still need to look at what quadrant you're in for the signs to use the appropriate sign as well, positive or negative, depending on the quadrant. So I'm going to turn this into, change it from sine of, I need to have either two numbers added together, sum, or two numbers subtracted together, difference, to make 105 degrees, using familiar angles to where either you're using 30, 60, 45, or it's a reference angle of 30, 60, 45. So I'm going to turn this into sine of 60 degrees plus 45 degrees, because 60 degrees plus 45 degrees is 105 degrees. Okay, because I have sine of one angle plus another angle, that is the sum identity, because I'm adding the sum identity for sine. The formula for the sum identity for sine is sine of A plus B, two angles added together, equals sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. That's how that is read. So basically here in our problem, this represents A, this represents angle B. Okay, so we basically have sine of 60 degrees plus 45 degrees. 60 and 45 are both in quadrant 1. Everything is positive in quadrant 1. Okay, so all I'm doing is replacing everywhere I see an A, I'm replacing it with 60 degrees. Everywhere I see a B, I'm replacing it with 45 degrees. So sine of 60 degrees plus 45 is sine of 60 degrees times cosine of 45 degrees plus cosine of 60 degrees times sine of 45 degrees. Okay, now we can take this information and now replace it with, these are the familiar angles of special angles. So now we can replace these. We're not using decimals, we're putting this in radical form. Okay, so sine of 60 degrees is square root of 3 over 2 times cosine of 45, square root of 2 over 2, plus cosine of 60 degrees, 1/2, times sine of 45, square root of 2 over 2. Order of operations, do your multiplication first. So multiplying fractions, square root of 3 times square root of 2 is square root of 6, all over 2 times 2, 4, plus square root of 2, my numerator would be 1 times square root of 2, just square root of 2, over 4. I already have a common denominator, yay, so just combine my numerator. I cannot add square root of 6 to square root of 2, they are not the same kind, so I just write it like that all over one denominator. So it turns out that sine of 105 degrees is the same thing as square root of 6 plus square root of 2 over 4. At this point, I always look to see if you can simplify your radicals. I can't, or reduce, because I don't reduce whole numbers with radicals, so it stays just like that. Don't reduce each one of these by 2. That's not a legal math move. Okay, now we're going to be looking at 11D1, the same thing. We're going to basically change this into adding of two numbers or subtracting two numbers, and those two numbers need to be familiar angles, either 30, 60, 45, or they have a reference angle of 30, 60, 45. Okay, I need to point out that there is more than one way to do this problem. You could turn this into an addition of two numbers. I'm going to turn it into a subtraction. So there is more than one way to do some of these problems, but the answer should always still be the same, no matter what way you go to do it, okay? So I'm turning this into cosine of 300 degrees minus 45 degrees, because 300 degrees minus 45 is 255. So basically I'm turning this into a cosine, a difference problem, subtraction. Another word for subtraction is difference. So I'm turning this into a difference with cosine. So you go to your difference identity for cosine. So the difference identity for cosine is cosine of one angle minus another angle is the same as cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Okay, so basically what I'm doing is I'm going to say cosine of my problem is 300 degrees minus 45 degrees. So I'm basically substituting everywhere I see an A, I'm going to use 300. Everywhere I see a B, I'm using 45. So this was a formula that I got from the book. Okay, so all I'm doing is taking this and plugging this into the formula. So cosine of 300 degrees times cosine of 45 degrees plus sine of 300 degrees cosine of 45 degrees. Okay, the one thing I want to caution you of is 45 degrees, that's in quadrant 1. Everything is positive in quadrant 1. 300 degrees. Okay, so we need to know what is the reference angle for 300 degrees and what sine, positive or negative, is cosine of 300 degrees and sine of 300 degrees going to be. Okay, so if I drew a little graph, 300 degrees is in quadrant 4. Okay, yeah. So there's 300 degrees, which means my reference angle is 60 degrees because that would be 300. So my reference angle is 60. So if I drew a triangle to get to this point down here, that's where I'm wanting to get to. Here's my triangle. I went in the positive x direction and then the negative y direction to get to this point. My hypotenuse is always positive. Okay, so looking at here, so in quadrant 4, cosine would be adjacent over hypotenuse, positive over positive. Positive divided by positive is a positive. So cosine is positive in quadrant 4. Sine will be opposite over hypotenuse. If I'm standing here at 60 degrees, this is opposite of me. Sine always goes with opposite, cosine always goes with adjacent. So sine is opposite over hypotenuse, negative over positive. A negative divided by a positive is a negative. So that tells me cosine is positive in quadrant 4, sine is negative in quadrant 4. And I'm going to use my reference angle of 60 degrees. So here, this is going to be a positive number, and I'm going to be using a reference angle of 60 degrees. Sine will be a negative number, and I'll be using a reference angle of 60 degrees. And that's where I will get my numbers. So, cosine of 300. Reference angle is 60, so I can look at cosine of 60, 1/2, and we said it was positive, so that's a positive number, times cosine of 45 degrees, square root of 2 over 2, plus sine of 300, my reference angle is 60, so I can look at sine of 60, square root of 3, square root of 3 over 2, and we said it was a negative number, so that's negative. I'm going to put it in parentheses to keep track of that negative, times cosine of 45 degrees, square root of 2 over 2. multiplication before you do your addition. Order of operation says to do multiplication first. So multiplying these two fractions would be square root of 2 over 4 plus a negative times a positive will be a negative number. Square root of 3 times square root of 2, square root of 6. 2 times 2, 4. Again, where does negative come from? A negative number times a positive, negative. So essentially I have square root of 2 over 4 minus, instead of writing plus and negative, I'm just writing minus, square root of 6 over 4. I already have a common denominator. I cannot combine square root of 2 and square root of 6. They're not the same kind, but I can write them together all over one denominator to say square root of 2 minus square root of 6 all over 4. And that is cosine 255 degrees. We just used the difference identity of cosine to get an answer. Okay, 11C1, tangent of 345 degrees. I'm going to choose to break this into tangent of 300 degrees plus 45 degrees. I'm going to turn this into a sum identity of tangent. Okay, so the formula for the sum identity of tangent is this. Tangent of the first angle plus tangent of the second angle all over 1 minus tangent of the first angle times tangent of the second angle. Okay, that is the formula. So in my case, I have tangent of 300 degrees plus 45 degrees. Basically, that is my A, that is my B. So now I'm just going to fill in for the formula. Tangent of 300 degrees times, or plus, tangent of 45 degrees all over 1 minus tangent of 300 degrees times tangent of 45 degrees. Okay, 45 degrees, that's in quadrant 1. Everything is positive in quadrant 1. 300 degrees, we need to figure out what quadrant that is in, what the reference angle is, and is it positive or negative. Okay, so 300 degrees, that's in quadrant 4. That would be going down like this. Okay, because that right there is 300 degrees, which means that leftover angle is 60 degrees, the reference angle. So if I was to draw my triangle to get down to this point right here, that means I went in the positive x direction, went down negative in the y direction to get to that point, and my hypotenuse is always positive. Okay, so tangent is opposite over adjacent. So if I'm standing here at 60 degrees, opposite over adjacent. Opposite, negative. Adjacent, positive. A negative divided by a positive is a negative. So therefore, this right here would be using the reference angle of 60 degrees. That's probably hard to see. That would be using a reference angle of 60 degrees, and it's going to be a negative. Same with down here. You're going to be using a reference angle of 60 degrees, and it's going to be a negative number. It's important to keep up with these signs and the reference angle. Okay? So, we said we're going to be using 60 degrees. Tangent of 60 degrees is square root of 3, and we said it was a negative number, so that would be negative. So tangent of 300 is negative square root of 3 plus tangent of 45. Tangent of 45 is 1 all over 1, there's my 1, minus tangent of 300, we said tangent of 60, which is square root of 3, and we said it would be negative. So keep up with parentheses. 1 minus a negative square root of 3 times tangent of 45, which is 1. Alright, let's simplify all this out. So in my numerator, I basically have, I'm going to rewrite it like this. 1 minus square root of 3 all over 1 minus negative times a positive. Negative square root of 3 times a positive 1 would be a negative square root of 3. 1, or minus a negative. 1 minus a negative, they both become positive. Keep up with your signs. So basically this just becomes 1 plus square root of 3. That's not your final answer. Can you leave a radical in the denominator? No. How do you get rid of the radical in the denominator? Well, if you didn't have this number here, you just multiply by square root of 3. But because you have the whole number plus a radical, the way you get rid of that radical in the denominator is by multiplying by the conjugate. This is back from Algebra 2. So in order to get rid of that radical in the denominator, you're multiplying by the conjugate. What is the conjugate of 1 plus square root of 3? Will be 1 minus square root of 3. Whatever you do to the denominator, you have to do to the numerator. I'm glad I picked this one for the video. So basically here, you're FOILing these out. Be careful with the numerator. You will have a middle term. Okay? FOILing these out. 1 times 1, 1. 1 times a negative square root of 3, negative square root of 3. Now do this one. Negative square root of 3 times a 1. Negative square root of 3 times a negative square root of 3. Positive square root of 9. I'll simplify in a minute. Now, FOIL out the denominator. 1 times 1, 1. 1 times negative square root of 3, negative square root of 3. Positive square root of 3 times 1, positive square root of 3. Positive square root of 3 times a negative 3, negative square root of 9. Keep up with your signs. Let's go to the numerator. Negative square root of 3, negative square root of 3. In debt one of these, in debt one of these means I'm in debt 2 of those. Plus square root of 9, which is plus 3, all over. What happens to these radicals? Cancel out. Negative of these, positive of the same of these, go away. So 1 minus square root of 9 is just 3. It's important for you to keep up with your signs. Okay, so on the numerator, I can combine my numbers. I can't combine my numbers to my radicals because it's not the same kind. 1 plus 3, 4. So this would be 4 minus 2 square root of 3 all over 1 minus 3, negative 2. Now here, you look to see, can you simplify your radicals? Can't simplify my radicals, but look at my whole numbers. This is a coefficient in front of my radical. If I can simplify all of my whole numbers by the same thing, then I can simplify. So actually, I should have circled that negative along with there because I'm going to simplify everything by a negative 2. I'm going to reduce all of my numbers by a negative 2. So in other words, if I reduce this by negative 2, 4 divided by negative 2 is a negative 2. Negative 2 divided by negative 2, positive 1. You don't have to write your 1. Negative 2 divided by negative 2, 1. But you don't have to write it over 1. So anytime you have a denominator of 1, you don't have to write it. So that should be your answer. Negative 2 plus square root of 3. That was a good reminder and review on conjugates. Okay, so now we're going to look at 11b, number 11. This problem says to verify. Also, the word verify means prove. You have this, cosine of 180 degrees minus theta equals negative cosine theta. You're trying to prove or verify the left side equals the right side. Notice here, this is a difference, 180 degrees minus theta, difference identity of cosine. So you have to use the formula for the difference identity of cosine in order to prove this. So the difference identity for cosine is cosine of A minus B is cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. What is in our problem? We basically have cosine of 180 degrees minus theta. In other words, we're going to say 180 degrees is A and theta is B. Everywhere I see an A, I'm replacing it with 180 degrees. Everywhere I see a B, I'm replacing it with theta. So I have here cosine of 180 degrees times cosine of theta plus sine of 180 degrees times sine of theta. Cosine of 180 degrees. You can literally just put that in your calculator. For these, you can put them in your calculator because this does not have a reference angle of 30, 60, or 45. So that's not one of the ones we have written down. This is actually on an axis point. 0, 90, 180, 270. So it's actually on the x-axis. So the easiest way to do it without going through the graph, you can verify it on the graph, but if you just put it in your calculator, cosine of 180 degrees is -1. And if you are pointing over here, then like -1. So that would be -1 times cosine of theta plus sine of 180 degrees is 0. So that is 0. 0 times sine of theta, 0 times anything is 0. So that whole term goes away. And so you end up with -1 times cosine of theta, which is negative cosine of theta. And that's what they were wanting you to prove up here. They were wanting you to prove that doing this, and you have to use the difference identity for cosine to go through to prove that it does equal that.